Good morning, friends. Today we will start with RCC structures. RCC structures are nothing but these are the structures which are reinforced cement concrete structures. Then, what is the difference between RCC structure and load bearing structure? RCC structure having slab, beam, column and footing, while load bearing structures having slab, and this slab is directly resting on wall. That is, the total load is transferred through the wall to the foundation, while in RCC structures the transformation of load is from slab to beam, beam to column and column to footing. So while designing any framed structure, that is RCC structure, we have to start with types of slab. In that first type is a one-way slab. Second one is a two-way slab. Third one a cantilever slab, and fourth one continuous slab. Now, what is a slab? A slab is a structural member. Slab is a structural member which forms floor and roof of a building. In our daily use, there are mainly two types of slab, that is one-way and two-way slab. Among that, we are going to study first one as a one-way slab. Now, what is a one-way slab? A slab is said to be one-way slab when the ratio of longer span to shorter span is greater than 2. Then that slab is designed as a one-way slab. See in this figure, suppose this is a room. The room having the dimensions, the longer dimensions are denoted by Ly always and shorter dimensions by Lx, though it is in any direction. The longer span is always denoted by Ly and shorter span is always denoted by Lx. Then how to determine this? This is a type of slab. Which type of slab we have to design? How to determine? For that you have to consider the longer span, measure this longer span, then take the measurement of the shorter span, then the ratio of longer span to the shorter span is greater than 2, then that slab is a one-way slab. Suppose this longer dimension is 10 meter and shorter dimension is 2 meter. Then 10 divided by 2, that is equal to 5. That 5 is greater than 2. Hence, that slab is designed as a one-way slab. That is, the longer span is 10 meter, shorter span is 2 meter, 10 by 2 is 5, which is greater than 2, then that slab is a one-way slab. So you have to remember, while designing any roof slab, you have to determine first the actual room sizes. In that you to determine the longer span and shorter span, and the ratio longer to shorter span ratio is greater than 2, then that slab is designed as a one-way slab. Now, what is two-way slab? As we know the one-way slab, now we have to know the two-way slab. A slab is said to be two-way slab when the ratio of longer span to shorter span is less than 2. Again, see here, the longer span is always denoted by Ly, shorter span is Lx. We are not considering the directions, only we are considering the length of the span of the room. That is, if it is longer, that is denoted by Ly, and if it is shorter, then it is denoted by Lx. Then the ratio of Ly by Lx is less than 2, then that slab is designed as a two-way slab, where Ly is a longer span and Lx is a shorter span. Here also, when we are going to design a two-way slab, what is use of two-way slab when it is provided? What is use of one-way slab when it is provided? Why one-way is provided? Why two-way is provided? Why for all the spans two-way slab is not provided? Why for one-way slab two-way slab is not provided? Or why two-way slab is not provided for a one-way slab? You have to remember. I am going to explain afterwards. So next is main steel and distribution steel. Then we have to remember what is main steel and distribution steel. In one-way slab, the main steel is provided along shorter span, while the distribution steel is provided along longer span. Then what is main steel? Main steel is nothing but it is a steel which is generally a torch steel, and in that torch steel is Fe415 and Fe500. Fe is nothing but ferrous and 415 or 500 is nothing but these are the characteristic strength of steel. That is, for Fe415, the yield stress, that is Fy, is taken as 415 Newton per mm square, and for Fe500 its characteristic strength, that is Fy, is equal to 500 Newton per mm square. And another one steel is there, that is mild steel, that is plain bars, that is 6 mm or it is 8 mm. That mild steel is denoted by Fe250, and here 250 is the characteristic strength of mild steel, that is Fy is equal to 250 Newton per mm square. We can denote mild steel by Fe250, or Fe250 means the mild steel. That is, when we are going to study about main steel and distribution steel, the main steel is always of diameter, that is 8 mm, 10 mm, 12 mm, 16 mm, 20 mm, likewise. And for distribution steel, it is 6 mm or 8 mm, or as per the design aspect. So you have to remember in this, for particular design, that is design of one-way or two-way slab, the main steel is from 8 mm to 8 mm, 10 mm, 12 mm, 16 mm, 20 mm and onwards. Likewise, the distribution steel is only 6 mm or 8 mm. In particular cases, 10 mm bars are also used as distribution bars. You follow this? This is very important for our study. Then why main steel is provided along shorter span? Now, as we know that here is a one-way slab. Here these are the two dimensions. One is longer dimension, second one is shorter span. Then we are going to provide the steel. That is, mainly two types of steel are there. That is a distribution steel and another is a main steel. Then in which direction main steel is provided and in which direction the distribution steel is provided, that is very important. So that if you are going to provide the main steel along this longer span, suppose when you are going to provide the main steel along this longer span and distribution along this shorter span, then what will happen? As we are going to provide the main steel along this longer span, the bending moment will increase. So the deflection of slab increases. This deflection of slab increases. If you are going to provide the main steel in this direction, shorter span direction, then the bending moment will be reduced, so that when we are going to provide the main steel and distribution steel, we have to consider the longer span and shorter span. If we are going to provide the main steel on longer span, the bending moment will be the more, and if you are going to provide the main steel on a shorter span, the bending moment will be less. So we have consider the less bending moment, because the deflection will be less, so the slab will be remain intact. So to reduce the deflection or bending moment, we have to provide the main steel in shorter span only, and distribution steel is provided along longer span, and this distribution steel is provided above the main steel. This is very important. So once again, the main steel is always provided along shorter span, while distribution steel is provided along the longer span, and this distribution steel is provided above the main steel. This is very important. Again, as a distribution steel, that is Fe250 or mild steel, we are only going to use 6 diameter bars or 8 diameter bars, while for main steel we are going to use 8 10 12 16 18 diameter bars. This is very important. Then next, the distribution steel is provided as, because we are learning the limit state method. In that limit state method, we have to apply all the concrete or all the steel in a limit. So the limit of mild steel, that is distribution steel, or for Fe250, if you are going to use the mild steel as a distribution steel, then that limit is, for distribution steel, is equal to 0.15%, that is 0.15 divided by 100 into gross area. Gross area, that is B into capital D. B is the width of slab and D is the overall depth of the slab. We will see the overall depth, how we are going to calculate. Then width, always we are going to design a slab for 1 meter length. That is, width is always taken as 1 meter, and depth we are going to design or we are going to assume. For torch steel, the main steel is provided as 0.12% of gross area. That is 0.12 divided by 100 into B into capital D. D is the overall depth, B is the width of the slab. It is generally taken as 1 meter. Now, as we are going to design this one-way slab, we have to consider or we have to assume certain data. Before that, we must know what is one-way slab, what is two-way slab, what is main steel, what is distribution steel, why main steel is provided along shorter span, why distribution steel is provided along longer span, why distribution steel is provided above the main steel. All these things are very important. We will see in next video lecture. Okay, thank you.